Hello, how do we solve this algebra problem? X to the power of 3 plus y to the power of 3 is equal to 152. Before we continue, we have a restriction, and our restriction is that x and y belongs to the set of natural number. What are natural number? Natural number are just counting number, which include 1, 2, 3, on and on like that. Now, let's go ahead and solve. Solution. Recall that a to the power of 3 plus b to the power of 3 is equal to a plus b times a to the power of 2 minus ab plus b to the power of 2. By comparing this left hand side with this, we have x plus y times x to the power of 2 minus the product xy plus y to the power of 2 equal to 152. The next step now is to consider 152. We can rewrite 152 in a couple of ways. 152 can be written as 8 times 19. We can also write 152 as 1 times 152. 152 can also be written as 4 times 38. Likewise, 152 can also be written as 2 times 76. Let us call this case 1 and this case 2, case 3, and case 4. We will now consider each case. For case 1, 152 equal to 8 times 19. That means from this line, we are going to have x plus y times x to the power of 2 minus product xy plus y to the power of 2 equal to, we will simply replace this 152 with 8 times 19, 8 times 19. Now, let us compare. By comparing x plus y go to 8 and x squared minus xy plus y squared go to 19. So we have x plus y equal to 8 and x to the power of 2 minus xy plus y to the power of 2 equal to 19. Let's call this the first equation and let us call this the second equation. From equation 1, this guy, x plus y equal to 8. Squaring both sides, we have x plus y times 2 equal to 8 to the power of 2. If you expand this guy very well, x plus y to the power of 2, you will arrive at x to the power of 2 plus 2xy plus y to the power of 2 equal to 8 to the power of 2 is simply 64. Let us call this the third equation. Now, consider equation 2 and equation 3. What do we have for equation 2? Equation 2 is simply x squared minus xy plus y squared equal to 19. X squared minus xy plus y squared equal to 19. And equation 3 is x to the power of 2 plus 2xy plus y to the power of 2 equal to 64. Let us now subtract these two equations. X squared minus x squared, that is 0, minus xy minus 2xy, that is negative 3xy, y squared minus y squared, that is 0, equal to 19 minus 64, that is negative 45. This implies that minus 3xy is equal to minus 45. Clearly, the negative sign takes care of each other. We are left with 3xy equal to 45. Dividing both sides by 3, we have xy equal to 15. Let's call this guy the fourth equation, equation 4. You will notice that we can now easily solve for x and y if we consider equation 4 and equation 1. Consider equation 1 and equation 4. Equation 1 says x plus y is equal to, and equation 4 is simply xy equal to 15. This is equation 1 and this is equation 4. From equation 1, this guy, x is equal to 8 minus y. When we transfer y to the right side, let's call this equation 5. Now, substitute equation 5 into equation 4. This is equation 4. We will now replace this x with 8 minus y. So we have 8 minus y times y equal to 15. 8 times y, that is 8y, minus y times y, that is negative y to the power of 2 equal to 15. This implies that y to the power of 2 minus 8y plus 15 is equal to 0. This quadratic equation is factorizable. Let's solve it. Y squared minus 8y could be written as minus 5y minus 3y plus 15 equal to 0. Y is common. We can factor it out. So we have y into y minus 5. Minus 3 is common here. We can factor it out also. So we have minus 3 into y minus 5 equal to 0. This implies that y minus 5 times y minus 3 is equal to 0, which in turn gives y minus 5 equal to 0 or y minus 3 equal to 0. Clearly, y is equals to 5 or y is equals to 3. Since x is equals to 8 minus y, from here, equation 5, x equals to 8 minus y, we will now consider when y is equals to 5 and when y is equals to 3. When y is equals to 5, so x is equals to 8 minus 5. Clearly, x is equals to 3. That means the first solution, which is s comma y, is equal to, when s is 3, we have y to be equals to 5. This is the first solution. Now, let us consider when y is equals to 3. When y is equals to 3, that means we will simply plug in the value of y, which is 3, into this guy. So we have x equal to 8 minus 3. Clearly, x is equals to 5. This means that the second solution, x comma y, is equals to x is 5 and y is 3. This is the second solution. You will notice that for these two solutions that we obtained, we have 3 comma 5 and 5 comma 3. This shows that x and y belongs to the set of natural number, that is 3 comma 5 is indeed in the set of natural number. We do not have any fractions or decimal. But for the other cases, that is for case 2, case 3, and case 4, if you try to solve it, you will observe that there is no positive integer solution for case 2, case 3, and case 4. That is, they do not belong to the set of natural number. That means we have to ignore case 2, case 3, and case 4. That's it for this video. Thanks for watching.